Let's talk about the more basic rules of probability using that same example with the 10 jelly beans. What we'll do is kind of connect the wording of what's being asked with how we would go about calculating it. So this first question here is kind of more direct probability in that they're just asking about the probability of some event happening. It's like, what's the probability of drawing a green jelly bean? So for notation, and you don't always need to write the notation, I am going to write it out because then you can see how the formulas are applied. But something that happens with probability is it can make more sense to think of it not in terms of the notation. I'm going to write it out, but it's not a requirement to write it out each time. But it can help when we get these formulas for the rules to be comfortable with at least seeing it, even if you're not comfortable writing it. So what I mean by this is probability of drawing a green jelly bean. With notation, I would write that as probability of green jelly bean. So that's going to be my short notation. With this, the idea of kind of knowing our sample space and the possible outcomes along with our sample size, I'm going to need to use a fraction to calculate this. So I have 10 total jelly beans, and then in the numerator I need the number of green jelly beans, which there are 3. And I just need the decimal form of that answer, which would be a 0.3. So I could say there is a 30% chance. And I'll give you a few different ways of writing sentences here. So a way of answering probabilities in terms of a percent chance. So with the question of what's the probability, I would say there's a 30% chance, and then the rest I would just kind of recycle and copy over of drawing a green jelly bean. So this is a possible sentence structure that you could use for answering probability questions. With part B here, what's the probability of drawing a purple jelly bean? So my event changed to a different color. So this is the probability of drawing a purple jelly bean. So out of the 10, I need to know how many are purple, which there are 2. So that'd be a 0.2. So another way of answering probability questions is instead of in terms of a percent chance, you can think of answering a little more directly. Either way is fine, but we could say the probability of drawing a purple jelly bean is and then 20%. So you can use those to kind of get started. Of course, there's so many other ways to phrase it, but if you need a guide, you can follow those structures there. All right, part C here. What's the probability of drawing a blue or red jelly bean? So, or is going to be a word that we want to look out for. When you see the word or, it's going to bring through addition. In fact, we'll have a whole video on this addition rule that's going to be related to when we look for the probability of one event or another event occurring. So with statistics, how we interpret or, and this can happen with some words in statistics where it's interpreted a little differently than how we interpret it in English. In statistics, when we see or, you want to think of we want one or the other or both. So it's like, I want to see what's the probability of picking a jelly bean and it's blue, or it's a red one, or it's both blue and red. Now this is a case where we don't have the both scenario. So in the video for the addition rule, we'll talk about when we have the case for both. We just don't have that in this one. So with this, if I want the probability of blue or red, what I'm going to do is add them up. I'm going to take the probability of it being blue plus the probability of it being red. So probability of blue, there were 1 out of 10, plus probability of red, 4 out of 10. And what we're really doing here is you're taking how many blue jelly beans plus how many red jelly beans. So these total 5 jelly beans that fit this blue or red scenario out of the total 10. But we can separate it in a formula like this. But again, you can kind of think of it in a roundabout way and get to the same answer, and that's Great, that works perfectly fine. So that's going to be a 0.5. So we could say is there is a 50% chance of drawing a blue or red jelly bean. So addition rule, we'll have a video on that, but that's going to come up when we see the word or. With part D here, what's the probability of drawing a jelly bean that is purple and blue? So and is going to be a key word. I know it's going to be a bit confusing, but I promise I'll break it down as best I can. And shows up in two different scenarios. This case here is the case for the intersection. The idea being that we're going to have one jelly bean with both colors. So one way that and is going to show up is having one thing holding two categorical variables. In this case, it would be purple and blue at the same time. So both could be a key word here. It could have even been in this sentence, like what's the probability of drawing a jelly bean that is both purple and blue. Another way we're going to see and show up is actually when we do calculations for and then, when it's going to be a sequence of events, like what's the probability of drawing a jelly bean that's purple and then drawing a jelly bean that's blue. And we'll have a different calculation that'll show up in the video for multiplication. But I'm going to keep bringing up this difference because it's a common mistake to mix these up, and it's rightfully a common mistake because the notation doesn't really change, but I'll make it clear. But this case here is where we'll write it as probability of purple and blue, and in terms of the calculation, what we want to think of is how many purple and blue jelly beans do we have out of all of the jelly beans? Now in this case, we don't have any jelly beans that have both colors. They're all just one color, so there are no jelly beans that fit this scenario out of the 10, which is just 0. So with this, it would be a 0% chance. This gets at the idea of disjoint, which we'll talk about more in the addition rule video, but the idea that these two events, they can't occur at the same time. So colors for our jelly beans are disjoint from each other. They won't overlap at any point. So that's our intersection where we're looking for two characteristics both at the same time. All right, and then the last rule that we want to look at here is what's the probability of drawing a jelly bean that is not green? So when we're looking for probability of not some event, we're going to apply this complement rule. And this, I mean, I could say this over and over for probability. There's so many ways to think about these, and it just depends on how your brain connects with it. And definitely, if you're getting to the right answers and you know how to think about it, go for it. 100%. I'm just going to show you with the notation and the technical math way, but if you find another way to this solution, that works great. I'll describe the way that a lot of students think about this question. So like probability of not green. Well, if we go back to our sample space here and think about all of our different values, saying not green is the same thing as what's the probability of drawing a jelly bean that's blue or purple or red. So you might be thinking in terms of adding those up, thinking 1 plus 2 plus 4. So we have those jelly beans that are not green out of the 10, and that is absolutely correct. There's going to be the 70% chance that the jelly bean's not green. And this works great for such a small set, but sometimes it gets more complicated. So, what if it was more complicated? This will bring us to our actual complement rule that we'll be using. In terms of notation with complements, we use this probability of the event, and then we use this C, it's almost like it's in the exponent, but it's just saying the complement, in this case, the complement of A. Or how I really should have written this probability of not green is this probability of green, but then to say not green, we put the C there. And it's C every single time to represent complement. So that's the notation you'll see for the probability of not something happening. So let's say this was more complicated. If there was this bag of 3,895 jelly beans with a variety of colors, I didn't even say how many colors there are, but let's say we had just the full Jelly Belly range of all the different flavors and colors. It is known that 825 of those jelly beans are purple. So what's the probability of drawing a jelly bean that is not purple? So first let's think about what's the probability that a jelly bean is purple. Well, we have 825 purple jelly beans out of the 3,895, which is a 0.2118. So that's our probability of getting a purple jelly bean. So if I want the probability that a jelly bean's not purple, well, if there's this 21.18% chance, I just want the opposite of that, which in terms of complements means kind of like the rest of that 100%. We have 100% of our jelly beans, 21.18% of them are purple, so the rest is not purple. So we want to figure out is what's that leftover amount with 100%. So what we can do is in the decimal form, think of 1 as our 100%, but then take out that probability of having a purple jelly bean. Take that 1 minus 0.2118, so you can figure out the rest of that percentage that makes up the non-purple jelly beans. So this would be a case of 78.82% of the jelly beans are not purple. And we could have done that up above here with the probability of not green. I could have gone 1 minus probability of green, which there were 3 out of 10, and get to the same exact answer. So you can think about it either way. It's just in some cases you'll want to use this rule because it can be applied more easily sometimes, especially with larger values where there are lots of different outcomes. If you want the probability of not some event, you take 1 minus the probability of that actual event. And it's like taking 100% and removing that event that you want to take out of there. So those are some basic rules of probability.